Let's talk about the future of databases. If you look at this project, which is something I recently discovered, which is VSQL, it's like Neon, which is for Postgres, but for MySQL. So in general, the database future, how it looks like, I think, is something where compute and data are completely differently stored, and data is going to be on S3 or something like S3, for example, R2 or Google Cloud Storage, things like these. So let's talk a little bit about this project, VSQL in general, and then I will share a few things what I think about this architecture in general. You can see that VSQL is a MySQL with innovative compute storage separation architecture, just like we have on Neon. Over here, all your data is on S3. So you basically have unlimited data capacity because there are pretty much no limits as such on S3, and it's extremely durable. So 11 nines of durability. Plus, I'm assuming if you keep backups of your data, occasional backups like every hour or every 12 hours or something, then that's also there. Then you have regional level disaster recovery, which is like free of cost, comes with S3, and up to 80 times reduction in storage costs for data archiving, which is something I think not a lot of people know, but S3 is extremely cheap. It's extremely cheap if you don't want to access your data. That's sort of like it might seem like puzzling that why would you want to even store data if you don't want to access it, but there are a lot of use cases. For example, some sort of historical data like videos or something which you want to keep but you don't want to access. You won't be accessing it as often. So if you store it into Glacier storage and things like these tiers, it's extremely cheap. Look at this. In general, S3 starts at the standard storage starts at 0.023 per gigabyte. But if you go down into infrequent access and Glacier access, for example, this S3 Glacier Deep Archive, it starts at 0.00099, which is very, very less compared to your typical system of 0.023. So you can see over here, it mentions a few things about this VSQL, which is obviously it's inspired by Neon. VSQL stores OLTP database data directly on S3, and it's built on VTES, which by the way is also how PlanetScale works, developed in Golang and offers agile features like branching. So I mean, in theory, it sounds good, but there are a lot of challenges that comes with it. And the biggest one is the latency between your systems, right? Because if we go into some sort of diagram, and if I try to show you how this works, basically, let's say this is your API server, for example, and it's trying to run some query, right? So it's trying to run select star from DB, whatever it is, right? Some sort of database. Now, when you run this query, there are two parts to it. The first one is the compute part of the query, right? Which is the actual place where, query planning is taking up. It's trying to understand how it has to run query, how it has to run the data, how it has to get the data, and so on. And the second part is the actual data where it is, right? Now, obviously, like some of the hot data is also just put in memory, but for the sake of argument, let's just realize that this is the data over S3, for example, for now. So this just can't work like this, right? So it won't be, it sounds like great that, okay, you can store all of your data on S3 and just, compute is just needing it as it requires it. But this can't work like this because S3 is an object storage, right? It's just raw data which is stored. However, your data, which is the actual database, it's much more richer than, just this object storage in general. You can see over here a couple of things which are challenges. The first one is obviously high latency because S3 is optimized for throughput, not low latency access, right? So what it basically means that even if you can, like, for example, do tens of gigabits per second of data transfer, it doesn't prevent you from the initial latency, right? So storing and retrieving data from S3 typically incurs higher latency compared to block storage like EBS, because in some cases you would be flowing the data over internet, but even if it is intranet, so you have like compute layer close to S3 in general, it still would incur this low latency issues, right? For example, users often expect a database write to return within a few milliseconds, where S3 write latency is around hundreds of milliseconds, right? So this is a huge problem. So even if you end up creating a structure like this, the performance would severely degrade for common use cases also, right? So obviously these are challenges which can be partially solved. And let's take a look at how VSQL addresses these challenges today. The first design principle they have said is that we separate the concerns of persistence and latency. So one of the key challenges in designing a cloud native database like VSQL is the inherent high latency of the object storage system such as S3, which we already talked about, right? So instead of writing every operation directly on S3, that system can use local storage, which is EBS or EC2 or whatever storage you have attached to the instance for latency sensitive operations. For example, bin log writes, which needs to be quick and reliable, reliable, can be stored in locally in low latency storage, and then it can be asynchronously uploaded to S3 in the background, right? So, I mean, again, like you try to solve one problem, the other problem appears, because if you're doing something like this, then your writes are eventually consistent, right? Because if you have other readers in the space, for example, instead of just going to S3 directly, let's say if you have like a SSD over here on the machine itself, and this SSD is like asynchronously communicating with that, what you would run into a problem is that, let's say if you have another compute which is like read only, now this whole system is now eventually consistent, right? So you can write something, and if you try to read it with your read replica, it would probably not be propagated by the time you read it, right? So it's possible. Design principle 2, log structured data structure. Log structured data structure is the first class citizen of S3. So adopting a log structured data structure is central to optimizing performance in systems that use object storage like S3. So it says that S3 is optimized for sequential writes and bulk operations, while it performs poorly with random and small writes. Now, reading about this, I just remembered that I think I just saw that AWS S3 now supports appends. I think this is something which I just recently read somewhere. Yeah, couple of days back. So this, I don't know how big of a deal this would be for these database systems, but AWS S3 now also supports ability to append data to an object, right? So you can now, instead of overwriting an object or creating a second version of that, you can just append the data on top of it, right? So log processing and all of that, if you want to just keep on continuously creating a log for one full day, right? So you can just keep on doing that, which is pretty neat. So I don't know how applicable this is for these new aged databases, new world databases, but yeah, something you should know about. So if you want to check the architecture, what they use basically in this is pretty much what we discussed over here. You have an application, then you have a connection pool, which is the VSQL, the whole thing. And then there is a data node they're using Kubernetes to handle all of this. So there is a data node, which pretty much is the actual compute, right? Which is talking to your S3 or whatever data engine you are using. Interestingly, you can see that if you read Neon's docs also, it pretty much follows the same principles, right? So instead of like appending the data directly to an object storage like S3, it appends the data in its local storage, replicates it into multiple availability zones, and then incrementally, or every once in a while, it just syncs it back to the cloud storage. And this is also something which Neon recently did, is that archive storage, right? So they have done a branch archiving as one of the new features. I'm not sure if this was the one. I saw some blog post with Neon that they're reducing storage cost, right? So yeah, the way they were doing it, that was by using AWS intelligent tiering, right? Which is like, shifting your unaccessed data to a different tier. But anyway, you can also see like pretty much they are doing the same thing, using a Kubernetes cluster to manage compute, and then the storage is on your object store. And plus the problems have been separated right now, because S3 is something which is so big, so humongous. It's like a company in itself. It's like a huge organization where you have to handle a lot of reliability, a lot of data. So it's perfect for databases in general, right? Where data is extremely critical, and S3 anyway provides a lot of durability out of the box. So Neon is one for Postgres. Now we have VSQL also. I would probably assume that more and more providers in this space would head towards a split architecture where compute is running separately, data is hosted separately, and yeah, let's see how it goes. Just out of curiosity, I was also checking out like how AlloyDB works, and you can go through this blog post because AlloyDB is the managed service by Google for Postgres, right? And this is something which we use at Fermion also. So all of the infrastructure and database of Fermion is on Postgres, and it works on AlloyDB. So as you can see, Alloy also works on a separation model, separation of compute and storage. And as you can see, Google also says that we just do a full compute and storage disaggregation, right? Even within the storage layer. So Google obviously has optimized it one step further because they have extremely high intensity read, write workloads in general in their own organization, right? So not only are they building infrastructure for you, but they pretty much use the same infrastructure themselves. Imagine something like YouTube, for example. So yeah, this model is there. it's just not available publicly, or for somebody like you and me to just spin up a compute, a Kubernetes cluster, and point in a S3 directory towards it. We still anyway, in one way or another, end up going to Neon or AlloyDB or AWS Aurora serverless, for example. But what I predict is that over the next few years, this is going to change, right? And there would be solutions which would be very easy to deploy at a very small scale also, so you don't have to break your bank, and they would be very highly available, right? So it will not be just a $5 VPS system which can crash and just take your database down. It would be ideally something like AlloyDB itself or Aurora serverless, but with the guarantees of data consistency, compute scaling up and down, and with minimal cost compared to running a database, right? So that's all for this video. Make sure you leave a like and subscribe to the channel. I will see you in the next one really soon.